Hi guys, and welcome to this, my video on drawing straight line graphs. How are you? My name's Darren, otherwise known as Maths Guru, and it is really good to see you. What are we doing? Yep, drawing straight line graphs, understanding that the equations are nothing more than a way to relate an x value and a y value. And I use the word relate along with the idea of relationships. Understand that x and y values are normally drawn on a Cartesian plane, understand what a straight line equation looks like, and be able to plot this on a graph of table of values. Oh, ka-ching! Now, if you haven't already done so, guys, can I ask you to subscribe to my YouTube channel? It'd be greatly appreciated if you could. I'm never going to be rich, never going to be famous, but it just shows me that you're watching, and realistically that means the world to me if you could. Thank you very much. There's also mathsguru.com, where I've got all of these videos with time codes and downloadable notes and exam questions, and you get access to loads and loads of stuff, and signing up is for free. Head over there and tell your mates if you can. Now, in our previous part of this course, and this is the general maths course, don't worry about it if you don't know what that means, because nor do I really. Math is a constant. I've only told that joke like 9 million times. In the previous lesson, we looked at the idea that a straight line can have two forms of an equation, and straight lines are really important. So this whole concept is about straight lines, this whole module about straight lines. And we knew that we could have y equals mx plus c, and we had the idea of ax plus by equals c. So for example, 2x plus 3y equals 6. Now obviously when we had these type of things here, we were solving them for simultaneous equations. I mentioned there the whole idea that they were straight lines, but now we're going to delve into it just a little bit deeper. Now, relationship with a bit of a difference. I don't quite know what I was talking about there when I planned this lesson, but it's important to know equation is nothing more than a relationship. It tells you how to find one value when you're given another one. So what I'm trying to say here is if you had y equals 3x plus 2. Now we know how to substitute. We've been doing that since year 7. Now x stands for a value and y stands for a value. So if I'm going to give you, for example, let's say the x value is 1. That becomes that y is equal to 3 times 1 plus 2. And again, it's really important to note that between the 3 and the times is a kissy, and you're probably asking, what on earth are you talking about? Exactly, but there is a times. So y becomes equal to 3 plus 2, or it becomes equal to 5. And what have we done here? I was given an x value, and I found a y value by using this thing here as the relationship. I gave you x, and it was linked somehow by this random relationship of times by 3 plus 2 to get a y value. Now obviously we can work out what one x value is, but what possible difference is it, or how useful is it just for one x value? Well, it isn't. But what we know with this y equals 3x plus 2 malarkey is that we can plot the output of lots of x values and their associated y values on a Cartesian plane. And I don't mean an aeroplane. The jokes don't get started, really, they don't. All right? We can plot it on that thing there, which is a Cartesian plane. And again, you've met these things before. So y to the yellow sun, I don't know why we said that. All right, y to the yellow sun, well, obviously yellow, and x is just the other one, all right? So we plot our coordinates going horizontally and then vertically. So a coordinate, this thing like 1, 2, is nothing more than a relationship between an x value and a y value. Hold our phone a moment, isn't that just what we had there? We had an x value and an associated y value. Ka-ching. So if I was going to plot the point 1, 2, the 1, that first value is always an x value, and that second value is always a y value. So I'm going to go 1 across, and I'm going to go 2 up, 1 across and 2 up. And in that situation, I put a nice, beautiful kiss. So let's put that into practice here with the straight line graph. And we'll start with something relatively easy. Let's draw the line y equals x plus 2. So let's just work out what that means. Take an x value, add 2, and that will give me the relationship of the y value. And these things can have many relationships. So let's start with the first one here. So when x equals 0, y is equal to x plus 2. X is 0 plus 2, which gives me 2. And so we'll just write the value of 2 there. Ka-ching, he does, doing a little dance. Now let's see what happens when x equals 1. Again, y is equal to x plus 2. In this situation, we know that x is 1. So 1 plus 2 is 3. And I could do all of this working out, but let's see if we can do this one in our head. So we've got an x value of 2, we know that x plus 2 is y. Take that value, add 2, I get 4. And you start to see a bit of a pattern. 2, 3, 4. So let's just check. The next one should be 5. So if I've got 3 plus 2, it is in fact 5. 4 plus 2 is 6. Ka-ching. There we go. We have our table of values. Now, I haven't got the table of values. We just have to remember that this thing here is nothing more than a set of coordinates. So now we're going to look at this first set of coordinates here, 0, 2. So when x is 0, y is 2. So again, we're going to go across and then up. So 0 across and 2 up gives me a kiss there. 1 across, 3 up gives me a kiss there. 2 across, 4 up gives me a kiss there. 3 across, 5 up goes a kiss there. Now obviously I've run out of room here. You guys will have grid books, which are phenomenally useful things for you. And so you'd make yours big enough. Now lots of people make silly mistakes here, because what they now do is either they don't join these together, and you really, really must, or they just join the 4 points they've got. Well, actually, nope, because we should extend that graph as a straight line, and using a ruler, we'd be able to do this really, really easily to the bounds of my graph. So what you got to remember is that this is almost like in a picture frame. So what I'm actually going to do is, if I had a ruler, that is my very not straight line. Now, obviously in an exam, you would get no marks for that, and probably I would write something very, very rudely embarrassing and undoubtedly terribly, terribly condescending on your work. But you're going to use a ruler for this. Notice we don't go any further than this bit here, and we don't go any further than that bit there. Now, one of the things that maybe your teacher will tell you to do, and I suggest you do, is that actually you should always put arrows on the ends of the line, because what that says is that you know that that graph will go to infinity and beyond. Here we go, we've got another one now. So we've got y is equal to, so what is it? Y is equal to 2x minus 1. So let's just check what that means. We're going to take y is equal to, we're going to take the 2 times x, we're going to double our x value, and then we're going to take away 1. So that's what that says, double my x value, and then take away 1. All right, so let's start with x equals 0. 2 times 0, let's just write this one out first. So y is equal to 2x minus 1. That's 2 times 0 minus 1. 2 times 0 is 0, don't get tricked. And 0 minus 1 is in fact minus 1. So that's my first value. Let's do one more. We'll do this. Y is equal to 2x minus 1. So that's 2 times, well in this situation, x is 1 minus 1. Well, 2 times 1 is 2 minus 1 gives me 1. And ka-ching. Can we see the rule that might be happening between? Well, we shouldn't guess until we got at least another value. So now let's say x equals 2. So 2 times 2 is 4, minus 1 is 3. Aha. 3 times 2 is 6, minus 1 is 5. And then because we see a bit of a pattern happening here, we see that they seemingly going up in 2s. So now let's plot our graph. Now obviously whenever there's a negative number, you go in the opposite direction. So because this here is a negative 1, I'm actually going to go down, not up. So I'm going to go 0 across and 1 down and put my little kiss there. Don't draw a massive kiss, just something nice. Then we're going to go 1, 1. So 1 across, 1 up. Then 2 across, 3 up, 3 across and 5 up. And again, I've run out of room. But what am I going to do now? Join these together. So joining them together, am I going to just join those 4 points there? Nope, we're really not, because this graph is actually going to go through that as well. Put my arrows on the end, and there we go. There is my equation or my graph of that straight line. And another one. They try and trick us. Why do they try and trick us? Because now we're going to have y is equal to 5 minus 2x. Ooh. Now, although it's been written the other way around, doesn't matter. We just have to make sure we do the math in the order that it's shown. All right, so let's start with 0. Y is equal to 5 minus 2 times 0. Again, between that 2 and the x's are times. Because we must make sure that we're following BIDMAS. Brackets, nut, indices, nut, division, nut, but there is a multiplication. So we have to do that 2 times 0 first. 2 times 0 is 0. 5 minus 0 is 5. And ka-ching, there is my first value. Okay, let's do the next one. Y is equal to 5 minus 2 times 1. Have to do the multiplication first. 5 minus 2 gives me 3. And ka-ching, there is 3. Can you guess the pattern? Well, let's just do one more. So we're going to do now. We'll do it over here, running out of room. So we're going to do 5 minus 2 times 2, or 2 2s are 4, 5 minus 4 gives me 1. And yes, I can see a pattern. It seems to be taking away 2 each time. So take away 2 from there, take away 2 from there, and we have all of my coordinates. So now let's cross. 0, 5 is going to go here. 1, 3 is going to go there. 2, 1 is going to go there. 3 minus 1 and 4 minus 3. And ka-ching, there we have my little kisses. What are we going to do? We're going to join them together. You're going to do it with a ruler. I'm going to try and do it with a nice straight line. Arrow on the end there, arrow on the end there. And so long as you do the bid maths and the order correctly, there really isn't anything too complicated to do this. Now we can use our CAS. I've got the TI Inspire, no longer the Casio ClassPad. I'll do instructions for those on another day. But if you've got the TI Inspire, we can actually use it to draw the line y equals 8 minus 2x. So again, the first thing you want to do is add a calculator. So yeah, you're going to go either onto that start screen or you're going to add, sorry, not a calculator. What am I saying? That first one seems to be a calculator. You're actually going to add a graph. So you're going to add a graph. When you do that, you get this. You're then going to bring up this section here, right? So you want to be able to enter the graph in. And what did I do? So you'll notice here I've got f1x. That's just saying let's add your first graph in. And they sort of go f2x, f3x, blah, blah, blah. What did I do? I then type in my 8 minus 2x, all right? So because we're doing the graph of y equals 8 minus 2x, now, did you need to put the y in? Nah, because your graph, your calculator with this f1x business, that in the calculator's head stands for y equals. So all I had to do was type in the 8 minus 2x, and when I hit enter, then out came this function here. And quite nicely, they wrote on there my actual function as well. And so ka-ching, ladies and gentlemen, my graph gave me that information. Now, obviously, if we go back here, not particularly helpful. Some of the graph seems to be going off, and much of what the information we want to be able to find with a graph are things like intercepts. So where it crosses the x-axis and the y-axis. So how did I do this now? Well, I entered menu on this one here, and then I came up to menu item 4, which changes the window and the zoom. And I was like, okay. And you'll notice they give you lots of different settings there. Box, in, out, standard. Most of these I don't use. Sometimes I use the zoom in, sometimes I use the zoom out. But in many cases, I want to actually do the settings myself. So I hit 1, and you'll notice up comes this dialog box here. Now it'll auto-populate the values, it'll probably be decimals, and I said, well, you know what? I want it to go from minus 10 to 10. So you'll notice it's got x min and x max. That's basically what is the maximum value on the x-axis and the minimum value. Scaling, leave it alone. Y min 5 and Y max 10. And then I hit OK, and what do you notice? It's now more centered. But more importantly, I can see where it crosses my x-axis and my y-axis, and they become really, really important to me. But how do I find those values? Well, again, you can now start tracing the graph, right? Now, when you're tracing, it's actually trying to give you values. So 5, again, menu 5, and I did graph trace. And what you notice is, then lo and behold, and I really don't know why I left that screen in there, but lo and behold, what we find is that suddenly I get this little cursor. And if you use the arrow keys left and right, it'll actually plonk up and it will plonk down. And what we can see with this one here is that I think that coordinate that it's highlighted is 3, 2. And again, that becomes useful a little bit later on. How do I get a table of values? This is another funky thing the CAS calculator can't actually do. Oh my goodness. Sorry, the Casio can't do, or at least I didn't know how it could do. You can actually get your table, your graph into a table. How? Again, bring up the menu. This time you type 7 and then you say, well, actually, I want a split screen table. And lo and behold, it gives you the graph on the left and this table on the right. And actually, it fills out X values for you. And the more you scroll that table, the more it actually shows. And in many cases, we'd be looking for values when X equals 0 or here when Y equals 0. Now that's going to come up again in a little bit in a later video. But pretty much that's it for this lesson. So we learned how to draw the graphs, draw a table with values, and use our CAS. There's a bit more coming in this video. Please watch it if you can. Subscribe, like, comment. Otherwise, I'm done. I'll see you again in another video, hopefully. Take care. Thanks very much for watching, guys. Yes, this is the end of another video. If you haven't already done so, can you click on my subscribe button? Yes, it doesn't mean anything other than the fact that I know that you are watching. Yes, it's greatly appreciated. Otherwise, I feel like I'm sitting here just talking to myself. And then, yes, there is maffsguru.com, of which you can see a still of now. And what is over there? Well, all the videos ordered by textbook, ordered by topic. You can search for the videos. You can download notes, time codes, exam questions, and so much more coming up. Yeah, it's absolutely free to join. So I'm done. Thank you very much. I hope to see you in another video. Give me a shout out to your mates if you can. I just want to make sure that everyone finds maths interesting and easy. All right, take care, guys. See you again. Bye-bye. Stay safe.